Hi, this is Ms. Oberly with Lesson 2-3, Conditional Statements. Today, by the end of this lesson, you will be able to analyze if-then statements and write the inverse, converse, and contrapositive. This idea of if-then statements is huge to geometry, so make sure you feel very confident about that. That's going to come up throughout the entire year. All right, so here are some words that you could add to your vocab section. First is the if-then statement. So if P, then Q, and if it's written in this form, then we could translate it into these symbols. So this arrow tells us we read it as if P, then Q. Or P implies Q, but we focus on the if-then. If-then is our biggie here. All right, hypothesis. The hypothesis of a conditional statement is the phrase immediately following the word if. So it's everything after if. Hypothesis is if. In symbols, that's our P. Conclusion is everything immediately after the word then. So when you see the word then, everything after it is our conclusion. In symbols, that's Q. All right, so identify the hypothesis and the conclusion in each statement. Remember, the key words are if and then. Do you remember what comes after the if? Is that the hypothesis or the conclusion? Do you remember what comes after the then? Hypothesis, if you said the forecast is rain, you are right. Conclusion, if you said I will take an umbrella, you are right. Let's try it again. A number is divisible by 10 if its last digit is 0. So if it's not written in if-then form, that's our first step. Do you see what our if part is going to be? If the last digit of the number is 0, then the number is divisible by 10. Awesome. All right, example 2, identify the hypothesis. Remember, that's the if part. And the conclusion, that's the then part, for each conditional statement. Then write the statement in if-then form. So a mammal is a warm-blooded animal. So we know this first part is going to be our if statement. That's our hypothesis. So if it's a mammal, then what do we know? It must be warm-blooded. So our hypothesis is a mammal, and our conclusion is it's warm-blooded. So if an animal is a mammal, then it's warm-blooded. All right. So here's a truth table that represents all conditional statements. So if your hypothesis is true and your conclusion is true, the statement will be true. If your hypothesis is true and your conclusion is false, the statement is false. That's the only time it's false. When the hypothesis is true and its conclusion is false. Otherwise, it's going to be true. Notice also that when the hypothesis is false, so that's here and here, the conditional will always be considered true. So the only time it's false is when the conclusion is false and the hypothesis is true. All right, so let's refer back to that in a moment. So a few more words to add to your vocab section. A conditional statement is a statement that can be written in the form if P, then Q. So these are the symbols. For example, here, if measure of angle A is 35, then angle A is an acute angle. The converse is formed by exchanging the hypothesis and the conclusion. So just writing the opposite. Q implies P. So the opposite of this statement would be if angle A is an acute angle, then measure of angle A is 35. So we just took this, which was our if, and we switched it to our then. And we took this, which was our then, and we switched it to our if. The inverse is formed by negating both the hypothesis and the conclusion, so making them opposite. So if the measure of angle A is not 35, then angle A is not acute. And the contrapositive is formed by negating both the hypothesis and the conclusion of the converse of your original conditional. So not Q, then not P. So if angle A is not acute, then it is not 35. All right, so for our last example, we're going to write the converse, the inverse, the contrapositive of the following statement. Then we're going to use the information at left, so actually it's to the right here, the information over here to the right, which is that cats in the genus Panthera include the leopard, jaguar, lion, tiger. These are the only cats that roar. So we'll have to use that information. They cannot, however, purr. So we're going to use this information to determine if they are true or false, and if the statement is false, then we're going to write a counterexample. All right, lions are cats that roar. So first, we're going to write our statement as an if-then statement. The conditional is that we have to use this if part. So if it's a lion, then it roars. So if an animal is a lion, then it roars. Based on the information at left, we know, or over here, this is true. Lions roar. All right, so now we're going to write the converse of that statement. Remember, converse just means we flip the Q and the P. So we're just going to flip around Q and P and write that as, if an animal is a cat that can roar, then it is a lion. So we literally just switch those around. So if it's a cat that can roar, does it absolutely have to be a lion? No, because a tiger is a cat that can roar, but it's not a lion. So if we can provide one counterexample, then we have proven it false. So that means the converse is false. All right, the inverse. Let's check the inverse. Remember, the inverse is the opposite of P implies the opposite of Q. So remember, in this case, this is P and this is Q. That's important to remember. So we're going to write the opposite of P and then the opposite of Q. So if an animal is not a lion, then it's a cat that cannot roar. All right. Now, remember, the inverse will be true if we can find, let's find out here. So if an animal is not a lion, then it's a cat that cannot roar. So if it's not a lion, then it's a cat that cannot roar. What do you think? Well, we can think of a tiger, which is not a lion, but that's a cat that can roar. So this is a counterexample that proves that that is false. The contrapositive, remember, is going to be the opposite of Q implies the opposite of P. So if this is Q, we're going to say if it's not a cat that can roar, then it's not a lion. So this is opposite of Q implies opposite of P. So we just have to use that formula. Based on the information at left, so if it's not a cat that can roar, then it's not a lion. This must be true. Check to see if the ones that are logically equivalent statements have the same truth value. Well, the conditional and the contrapositive should be the same, and they are both true. Let's see, this one is true, and the conditional is true. And we know the converse and the inverse should both be the same, and they are both false.